Online lecture series, computational methods using Matlab programming. So lecture number 5. So in this lecture we will discuss about vectors in Matlab. So how to create a vector, how to manipulate a vectors, then apply arithmetical operation, how to apply arithmetical operations on vectors, then we will discuss the remaining concepts on vectors. So this is the most important concept in Matlab programming. So every variable, and in Matlab programming, every scalar or every variable, every number is represented in matrix form only. Matrix is nothing but two-dimensional array. So vectors is the one-dimensional array. So this is also quite very easiest concept in Matlab programming. So now we will discuss about vectors in Matlab program. So now this is the layout for our Matlab software. Then how to create the vectors in our Matlab. So now we will discuss one by one. So vectors is a one-dimensional array of numbers. Matlab allows creating two types of vectors. One is row vectors and column vectors. So we can create the vectors in two types. One is row vectors and other one is okay, I will write here. Just 1 minute. Okay. Now, so vectors. So we can create the vectors in two types. One is row vectors and other one is column vectors. Then how to create a row vector and a column vectors? Okay, we will discuss one by one. So how to create a vector, row vector? First creating a vector, then we will discuss the row vector and column vector. So first we will discuss about how to create the row vector. Row vectors are created by enclosing the set of elements in square brackets using space or comma to delimit the elements. Very simple. It is very simple. Suppose if you want to create a vector is nothing but one-dimensional array. Suppose if you want to create a vector, very simple, starting from square bracket and closing with square bracket, then write the elements, whether it is numbers or string, whatever it may be. So we can separate the elements by space or using commas. Then so we have two types of methodologies for creation of row vectors. Row vectors. Then how to create the vector. Okay, this is very simple methodology. We now go to create a vector in our software. Okay. Then suppose I will take x equals to, now starting with square bracket. Now this is the syntax for vectors. Now write the numbers 1, then space 2, then space 3, then space 4, then space 5. You can write any number of elements. So if you closing with semicolon, output suppressed. No output will be displayed, but it is executed but no display. Now if you want to know the output of x, so if you want to know the x value, then type x, you will get the vector. Now this is the first methodology. Okay, I will write the same vector without, okay, I will write with another index. I will take x1. Already we discussed the variable name. So we can write the same vector without semicolon. Directly you will get the output. Output in the previous case suppressed, here no suppressed. Now coming to clear screen, CLC. Now I will take another vector in the same fashion, x2 equals to square bracket. Now, separation with commas, elements separation with commas, 4, okay, 4, 5, and closing with semicolon, or then no problem, without semicolon directly you will get that. So, this is the procedure for creating row vectors. Suppose if you want to create the column vector, it is very simple, separate the elements with semicolon. Now observe, semicolon 3, semicolon 4, semicolon 5, closing bracket, then you will get the vector in column wise. Then what is the methodology for creating? This is the methodology for creating row vector. This is row vector. Now how to create the column vector? Very simple. Sum y equals to, now 1 semicolon, 2 semicolon, 3 semicolon, 4 semicolon, 5. Then you will get the column vector 1, 2, 3, 4, 5. Very simple methodology. Okay, we can create the column vector in this fashion, in this methodology, in this syntax. So row vectors is very simple. So separate the elements with space or comma. Here with separating with semicolon, you will get the column vector. Okay, I will show you again. CLC. Suppose if you want to create A equals to, okay, not only numbers, we can create the strings A, okay, B, okay, now I am separating with semicolons, C, then closing braces, then directly you will get A, B, C. Okay, this is a different methodology. Okay, okay, now we will discuss later in detail. Now coming to next topic in vector subject. So this is a creation of vectors and row type vector and column vectors. Okay, now we have created the row vector and column vector. We can create two types of vector. One is row vector and other one is column vector. Very simple. Here separation with space or comma for row vectors. Here separation with semicolon, you will get the column vector. Now reference element of the vector. Now listen, very important point. Now listen, I will explain. Okay, suppose if you are created a vector x equals to 1, 2, 3, 4, 5. Now this is the first element. Second, okay, I will take 10, 20, 13, 14, 52, 55. Okay. Now this is the first element, second element, third element, fourth element, okay, fourth element and fifth element. So this is first element, second element, third element. So simply it can be represented as x of 1, x of 2, x of 3, x of 4, x of 5. Okay. Then I will show you in the software. Okay, CLC. Okay, I will take some A1 equals to, I will take A1 equals to, okay, otherwise I will call x. X is a vector. Now what is x of 2? Second element of x is 2. Okay, suppose if you call x1 vector, okay, so all are similar vectors. Okay, I will take another example, control C, sorry, CLC. Okay, I will take A1 is a vector, okay, 12, 20, 23, 32, and 56, then 59, okay, separation with the spaces, then no problem. Okay, suppose if you want A1 value, directly type A1. Suppose A1 of index. Suppose if you want to find fourth element, directly a1 of 4 equals to 56. Very simple. Now this is the indexing. So very simple method. What is the method? First name of the vector, then open bracket, then write the reference number 1, 2, 3, 4, starting with 1, 2, 3, 4. So you may write any number I. I is 1, 2, 3, 4 depending on the vector. Now this is the methodology for indexing. Indexing or indexing the element of x, vector x. Okay. Very simple. Now coming to another one. Already we discussed. Now coming to V semicolon. When you reference a vector with a colon, suppose if you use colon in such a way, V colon, all components of the vectors are listed. Okay. Okay, I will see in our software. So if you write x of semicolon, only colon, not semicolon, colon. Then what happened? Sorry, colon shift. Okay. Then you will get the all the elements of x. Suppose if you write a1 colon, then what happened? Colon, not semicolon, colon. Okay. Then what happened? All the elements. Suppose if you know a of colon, okay, what happened? The elements of a are a, b, c. Already we discussed. A vector a is already discussed in our earlier part of this lecture. CLC. So this is another way. We should know. We should use the colon operator for knowing the elements of vector. Now coming to subvector or subset of a vector. Matlab allows to you select the range of elements from a vector. Okay, I will explain one by one. I will explain one by one concept. Okay. Suppose if you, I will give one example. A vector is created, just for example 10, 20, 30, 40 and 50. After creating this vector, now how to print 20 to 40 like this? How to print this vector from using this vector? Very simple. We can use the colon operator. Suppose if you use x colon, you will get all the elements in x. Suppose if you use x of, so 20 is the first, second element, third element and fourth element. Use colon 3. This is nothing but 2 colon 3. Already we discussed the colon operator in our earlier class. Colon operator is nothing but, so this is fourth element, second, third, fourth index. So 2 colon 4 is nothing but 2, 3, 4. So x of, just for understanding, x of 2, 3, 4, nothing but x of 2, x of 3, x of 4. So what is the second element of x? What is the third element of x? What is the fourth element of x? Simply we can write in this fashion only, in this methodology, in this manner. X of colon 2 comma 4. Okay. Already we discussed how to generate the numbers from one number to another number. Okay, I will show you. 2 colon 4 is nothing but 2, 3, 4. Already we discussed. Suppose if you want to type 2 colon 9, you can get all the positive integers from 2 to 9 with increment 1, 2, 3, 4, 5, 6. Suppose if you write in this form 2 to 4, so this is not acceptable form. So first element must be lesser than the second element, that's why you will get an error. Okay, CLC. So 1 colon 90. So generating all the 1 to 90 numbers using colon operator. Okay, CLC. Suppose if you write 1 colon 2 colon 7, then what is the meaning? So starting number is 2, 1, so ending number is 7 with increment 2. Increment 2, 2, 2, 2, 2. Okay. Suppose if you write 1 colon, okay, 1 colon 5 colon 46, then what is the meaning? So starting from 1 to 46 with increment 5, 5, 5, 5, difference is 5. Suppose if you write the same with up to 45 only, then what happen? So you will get only 41. So because ending number is 45, for next number is 46, 45 is our dead number, n number. So you will get up to 41 only. Okay. Now clearly I will explain one more point. Suppose if you write 1 colon 4, you will get what happened? 1, 2, 3, 4. 4 colon 1, you will get another. Okay. 4 colon minus 1 colon 1. Then what happened? 4 decreasing number, 4, 3, 2, 1. So with difference minus 1. So in this form, this is acceptable syntax. This is 4:1 is not acceptable. Here acceptable is 4 colon minus 1 colon 1. Okay, I will repeat again. I will explain with another example. 23 colon decreasing number, 20 colon minus 2 to 9. Sorry, minus 2 colon 9. So now we will generate the numbers 23 to 9 with increment minus 2. Nothing but decreasing, 23, 21, 19 up to 9 only. So for decreasing numbers we can use negative sign in middle of these two. Okay. Using this concept CLC, suppose if you type x equals to 1, 2, 3, 4, okay, I will take x1 of 2 colon 5. What is the meaning? What is the meaning? 2 colon 5 is nothing but 2, 3, 4, 5. Second element, second, third, fourth and fifth. Second element of x1, third element of x1, fourth element of x1, fifth element of x1, simply you will get 2, 3, 4, 5. Now this is the procedure for finding the subset or subvector or creating another vector using the same vector, CLC. Okay, now coming to first way. Okay, I will explain with another one. So this is already we discussed, colon operator. Okay, and then before going to the vector operators, I will explain one more very important points for subsetting concept. So A1 equals to this one. Okay, suppose if you write A1 colon 2 to 3. So second and the third element of A1. Okay, I will explain here. Suppose if you write x for here A1 of 2 colon 3 is nothing but second and third elements of A1, nothing but A1 of 2, A1 of 3. So A1 is the first vector, created vector of second element of A1, third element of A1. So directly you will get the value 23, 20, 32. Okay. Suppose if you write like this, okay, I will write A1 square bracket, sorry, open bracket, square bracket of 1, 3, 5 colon. Then what is the answer? Simply check it. What is the meaning? I will write here. I will explain here. A1 of bracket is nothing for indexing. Here 1, 3, 5. 1, 3, 5. Again it is a vector. Again it is a vector. So first element is 1, nothing but a first element of A1. Now second one is 3. A1 of 3, A1 of 5. So nothing but first element of A1 is 12. Third element of A1 is 32. Fifth element of A1 is 89. That's why you will get this one. Okay, we can write in another fashion also. Suppose if you want to write in another way, okay, inside vector is 1, 1, 3, 5. Okay, A1 of K. A1 of K. K is 135. This is same as our previous one. So both are same. Suppose if you write A1 of some variable is a vector 135. This both are same. You can write in this fashion or in this manner. Both manners are same. A1 of K. K, what is K? K is a vector 135. So first element of A1, third element of A1, and fifth element of A1. Okay. And one more, another very, very important point. Okay. I will write A1. A1 of, okay, A1 is less than 30. Then what is the meaning? So in A, now observe this one. This is very, very important point. A1 of A1 is less than 30. So first execute this one. What are the elements less than 30 in A1? A1 in A1, what is A1? This is A1. Okay, I will copy here. Okay, this is A1 less than 30. First element, second element only, less than 30. So what happened? A1 of less than 12, 32. Okay, what happened? Now you will get an error. Why? What happened? So less than A1 is 30. So 12 and 23. Now this is treated as a vector. 12th element of A1 and 32 element of A1. Then what happened? Invalid expression. Check the missing manipulation. Okay, all these things. Okay. What happened? Okay. Now listen. Sorry. Now I will write here. Now the wrong. Sorry. A1 is less than 30. In A1 less than 30. Now listen. Wait. I will explain. Sorry. This is wrong. Not like this. Sorry. A1 less than 30. Now you will get the truth value. Now truth value only. A1 less than 30. Yes. What is the truth value? A1. Truth value is true. Then false. Sorry, this is also true. False. So now check this condition. You will get the truth value. Whenever it is true, it displays first element and second element. You will get 12 and 23. Okay, in this session I will explain with another example, don't worry. Okay, I will take CLC, sorry. Okay, I will take Z equals to first element is 1, second element is 4, third element is 78, fourth element is 32, then 0 and minus 3 and 45 and 99. Okay, I will take the big vector. Z is a big vector. Suppose if you want to know this value, okay, then find Z of Z less than 15. Now check one by one. So Z value, now Z less than 15. So this is it true? Yes, it is true. So you will get the first value 1. So 4 less than 50, this is true. You will get the corresponding value. 78 less than 15 is false. So it does not display. Does not display. It displays not true, not true. What is the answer finally? So it is true when 4140 minus 3, you will get the value. So we can find the subsetting of a vector using logical operators also. In the similar way, we can use Z greater than 15, then what happens remaining elements? So greater than 15, 72 and 32, 45, 19, because at 1 you will get false, at Z greater than 15, this is false, false, true, true, false, false, true, true. So find out the true values, then you will get the corresponding values, or taking the corresponding indexes. Okay, whenever it is true, take the corresponding index. So directly it displays the values. Okay, use logical operator, and also we can use other logical operators. Okay, I will show you. Z of Z is less than 10 and okay, Z greater than 45. Then what happened? So what is Z? What is Z? Less than 10, less than 10, less than 10. So what are the less than 10? 1, 4, these are, and Z greater than 5, Z greater than 5. So if you use and symbol, you will get an error. Suppose if you use what happened, R symbol, so element wise, so what happened, both less than 10 and greater than 45. Less than 10 is 1, 4, 0, greater than 45 is also no counted. Less than 10, yes, this is true, less than 10, less than 4, this is greater than 45. Okay, this is not true, this is less than 10 true, this is less than 10 true. So greater than 45, this is false, this is also greater than 99. So find out the value. So we can use or operator, and operator, less than, greater than, for finding the subsetting of vectors. Now coming to next topic. So next topic in vectors, that one is vector operators. Then how to add, subtract, and etc. etc. Okay, we will discuss one by one. Suppose if you create a vector x 1, 2, 3, 4. Suppose if you create another vector 3, 4, 5, some 7. So both are same. If both the dimensions are same, then only we can apply operators on x and y, addition, subtraction, etc. Suppose if you want to find the value x plus y, very simple, then add the corresponding numbers 1 plus 3, 2 plus 4, 3 plus 5, 4 plus 7. Corresponding elements, apply this operator. You will get 4, 6, 8, 10, 11. In the similar way, suppose if you want to find the subtraction, very simple, 1 minus 3, 2 minus 4, 3 minus 5, 4 minus 7, you will get the corresponding values. So what are the values? Minus 2, minus 2, minus 2, minus 3. Okay, then no problem. Suppose if you apply star operation, what happened? Division, what happened? And also power, what happened? Okay, we will discuss one by one. Okay, after completing these two operators, we will discuss one by one on the software. So x equals to 1. Okay, I will take the same example just for verification. 1, 2, 3, 4. Okay. 1, 2, 3, 4 means I will use column operator 1, colon 4. Directly you will get x value. Now I will give y vector. We can separate it with semicolon or comma, then no problem. We can assign multiple variables in a single line. So other one is vector, I think 1, 3, 4, 5, 7. Okay, fine. 3, 4, 5, 7. Okay, separating with semicolon. So what is x? X is this one, y is this one. Okay, x plus y is adding the corresponding elements 1 plus 3, 2 plus 4, 3 plus 5, 4 plus 7. X minus y, what happened? T is an undefined variable. X minus y. So already we discussed subtraction. Okay, I will write again. X, y, x minus y. Okay, 1 minus 3, 2 minus 4, 3 minus 5, 4 minus 7, you will get this value. Okay, suppose x is known, y is known, x into y. X into y is totally different. X into y is totally different. Suppose if you want to multiply in this fashion, okay, I will show you. Element wise multiplication, 1 into 3, 2 into 4, 3 into 5, 4 into 7, then use dot star. You will get the corresponding element 3, 8, 15, 28. In the similar way, element wise division, use dot. Element wise power, use dot star. So division is 1 by 3, 2 by 4, 3 by 5, 4 by 7, you will get the corresponding value. In the similar way, power is nothing but 1 power 3, 2 power 4, 3 power 5, 4 power 7. So use dot star, dot division, dot power. You may use left division or right division, then no problem, use dot. Okay. CLC, okay, I will write again, x, y, then the x, dot star, sorry, dot asterisk y, then you will get the 1 into 3, 2 into 4, 3 into 5, 4 into 7. Now this is the symbol. X dot division y. So already we discussed it. X dot correct y. So element wise power 1 cube, 2 power 8, 2 power 4, 3 power 5, 4 power 7. You will get the values. Okay. So this is about multiplication. So addition, subtraction, element wise the multiplication, element wise division, element wise power. In the similar way we can apply, suppose x equals to some value. Suppose if you want to find sine of x, then what happen? What is the meaning? Sine 1, sine 2, sine 3, sine 4. Suppose if you want to find log of x, nothing but log 1, log 2, log vector, log 1, log 2, log 3, log 4. In the same way, exp of x, then what happen? E power 1, e power 2, e power 3, e power 4, because x equals to 1, 2, 3, 4. Suppose if you want to find trigonometric, exponential, x power, log, now square root, sqrt, square root of x is nothing but square root of 1, square root of 2, square root of 3, square root of 4. So very easily we can write any function. So we can apply any, suppose if you know 1, 2, 3, 4, 5 or 4, sine of x is nothing but sine of 1 element wise, sine 2, sine 3, sine 4. In the similar way, if you replace sine by cos or tan or cosine, cosecant, they will get the same. Suppose if you write log value, log. So square root, exponential function, directly it will be evaluated. Now coming to scalar multiplication. Suppose if you want to multiply with some constant number, okay, CLC, x is known. So now I will multiply with x star 6 star x. So multiplying with 6 into 1, 6 into 2, 6 into 3, 6 into 4 is nothing but scalar. Multiplying with the scalar quantity. Vector quantity is x and 6 is the scalar quantity. Multiplying with 6 is nothing but 6 into 1, 6 into 2, 6 into 3, 6 into 4. Very easy. Okay. Suppose if you want to transpose the vector, okay, very easy. Suppose if you use x single quote is nothing but transpose of the vector. Now this is x is a row vector. Suppose if you want to find column vector, simply use x single quote for finding the transpose of the vector, row vector to column vector to row vector. Now appending of vectors. Suppose if you want to add two vectors, very simple, CLC. Now listen carefully. Suppose we have a vector x equals to 1, 2, 3 or 1, 2, 3, y equals to another vector 10, 20. Suppose if you add these two like this, again these two, so some call it as some k, then what happen? First elements of x, then elements of y, 1, 2, 3, 10, 20. Okay, we can separate with comma or semicolon. Semicolon is totally different, comma or space. Okay, we can write in this fashion. Suppose if both the dimensions are same, suppose x1 equals to 10, 12, 13, y1 equals to 12, 13, 14, then suppose if you use semicolon between these two variables, okay, I will call it as k1, then what happens? First x1 vector 10, 12, 13, then Semicolon means in the second row it displays 12, 13, 14, nothing but a vector. So 2 by 3 vector, 2 by 3 matrix, 2 by 3 matrix. Now this is a very simple procedure I will explain in our software. X equals to 1 colon 3, okay, known 1, 2, 3. Y equals to 13 colon 15. Okay, I will take 2 vectors here equal to. Okay. So 2, 13, this is 13. 13, 14, 15. Now 2 vectors are created. Suppose if you want to know x, y. Okay. CLC. Okay. Now suppose if you append, so add the two, not addition, add 2 vectors into a single vector. Very simple, I will write another name k, square bracket of x comma y. Okay, you may use, okay, I will take the square bracket only. Now 1, 2, 3, 13, 14, 15. You may use space also between these two. You will get the same. Suppose if you use semicolon between these two, if both the dimensions are same, dimension of x and dimension of x, the number of elements in x is nothing but the dimension, then you will get a matrix 1, 2, 3, 13, 14, 15. Very simple. So this is nothing but appending of vectors. Okay, already we discussed. Suppose if you want to find the dot product. So previously dot star for element wise multiplication. Suppose if you want to find the dot product of 2 vectors, CLC, okay, sorry, CLC, x is known, y is also known, x dot y is nothing but dot star y is nothing but element wise multiplication. Suppose if you write dot of x comma y, then what happen? Dot product 1 into 13 plus 2 into 14 plus 3 into 15. Okay, I will explain on whiteboard. So first vector is 1, 2, 3. Second vector is 13, 14, 15. If both our dimensions are equal, then write dot product of x, y. So 1 into 13 plus 2 into 14 plus 3 into 15. So 13 plus 28 plus 45. So 30, 41, 86 is the answer. So dot product. So dot product is this one, a1 a2 plus b1 b2 plus c1 c2 formula. Suppose a bar equals to a1i plus a2j plus a3k, then b bar equals to b1i plus b2j plus b3k, then a bar dot b bar equals to a1 b1 plus a2 b2 known, a3 c3, sorry, a3 b3. So you will get the same. This is the procedure for finding the dot product. So which is shown in our display. X, y. This is element wise multiplication. Dot product of x comma y is 86. Okay. Now line space. Now listen carefully. Okay, we can create another vector using line space operator. Okay, so this is vector with uniformly spaced f n 1. Okay, we will discuss later that one. Line space function. So line space function, so starting number, last number, number of elements. Okay, very good. Okay, I will write line space of starting number is 1, ending number is 10, then number of elements is 5. So totally 5 elements only. So starting from 1 to 10. Now total we want only 5 numbers only. 5 numbers only. Then you can get the value. Very simple formula. Very simple formula. So b minus a by n minus 1. B is 10 minus 1 by 4. That is 9 minus 9 by 4, 3, 9 by 4. Okay, we can find 9 by 4. 9 by 4. So 2.25. So 2.25. Then what is the meaning? This is nothing but spacing. So first value is 1, which means 2.25. So second value is add this one 3.25. Again add this one 5.50. Again add this one 7.75. Add the same value 10. So this is the procedure for finding the line space function. So line space function is what is the starting number, ending number, then n. So for finding the difference, very simple, b minus a by n minus 1. Directly you will get the line space function. Okay, I will write one more. Suppose if you take 3 only, then what happen? 10 minus 1 is 9 by 3, 3 difference. 9 by 2, 9 by 2, 9 by 2 is 9 by 2, 9 by 2 is corresponding value, 9 by 2 is 4.5, 1 plus 4.5, then 4.5 to plus 5.5, you will get this value. Suppose if you take line space I will take 4, then what happen? 9 by 3, 9 by 4 minus 1 is 3, so increment is 3, 1, 4, 7, 10 and so on. This is the simple methodology for finding the line space function. So in the next class we will discuss about matrices, then how to create the matrix, and then how to manipulate the matrices, then how to apply the operators on the matrices. Okay, so we will discuss all these things in lecture number 6. Sixth lecture is matrices in vectors. Okay, I will stop here. Thank you very much. If you have any doubts, then this is my WhatsApp number. Send your doubts to this WhatsApp number, and also if you have any doubts, contact me through my email ID. Okay, thank you very much. Meet again. Bye.